Hello friends, welcome to our Flutter course. Today we have a very important topic, FutureBuilder. We'll discuss how it works, why it's needed, and how to use it to create asynchronous operations. In the previous video, we started exploring HTTP requests in Flutter and wrote a class to handle network requests. In this lesson, we'll connect this class to the user interface. Let's begin. First, I suggest removing all the widgets we currently have, as we're going to start from scratch. To do this, simply clear everything in the main file except for the main method. I also suggest continuing to separate classes into files because it's better practice than writing multiple classes in one file. Let's start with the class for our application. We'll call it Users App. This will be a stateless widget that will build a material app. We're already familiar with its parameters, particularly the home parameter. Here, we need to pass either a scaffold or a widget with a scaffold. For now, let's pass an empty container to avoid IDE errors, and then we'll start creating the widget in a separate file. We'll call this widget Main Page. It will be a stateless widget. In the build method, we need to return a scaffold. This will be the main page where we'll display a list of users from the API. Let's start with the app bar. As we remember, it's created like this. We pass an app bar object. Let's give it a title. We'll pass in a simple text widget containing the name of the app. Now, we can style it. However, it's better to do this not directly through the text class parameters, but via the title text style parameter from the app bar class. It also accepts a text style object. Next, let's add a button to our app bar, which will allow us to send users to the server. As we remember, this is done through the Actions parameter. Let's pass in an icon button with the Add icon. For now, we won't add any functionality in the onPressed method and we'll leave it empty. I also suggest changing the color of our app bar. Now, let's move on to the body of the scaffold. This is where things get interesting. Here's my suggestion. We'll make a request to the server, which, as we know, can take some time. While the request is being processed, we'll show the user a loading indicator using specific widgets. Once the data is received, the loading indicator will be replaced with the data. If an error occurs, we'll display that error. This is called state management. In Flutter, there are many ways to handle this, but today, we'll focus on the one specifically designed for working with Future. First, let's try creating an instance of the repository we wrote in the last lesson. We'll do this in the main page widget because it will be used there. As you can see, we're getting an error in the widget constructor. The issue is that when using shortcuts, Flutter creates const constructors. This type of constructor allows creating const objects, meaning objects that cannot change after creation. This improves performance. However, since we declared a variable that is not const, we can't use a const constructor. This is because the constructor requires all fields to be final or const. So let's simply remove const from our constructor. This isn't the best solution in terms of clean code, but we're doing this just for practice. In this course, there will be a lesson where we'll explore common code writing mistakes and how to avoid them. Now, let's use this repository in our interface. But how can we do that? Let's try calling a method in the build method. We need to add a wait so we can access the result. But what happens if we declare our method as async? This will lead to an error because we cannot modify the structure of overridden methods. This is where FutureBuilder comes in handy. FutureBuilder is a special widget that listens to a future and automatically updates the UI based on the state of the future. A future has 3 states: waiting while data is loading, done when the future completes, and error if something goes wrong. FutureBuilder automatically manages these states and updates the widget when the state of the future changes. Let's look at how FutureBuilder works. It has 2 main parameters. The first is future, which accepts any future object and listens to its states. In this case, we want to get a list of users, so we'll pass the result of the getUsers function to this parameter. Since this method returns a future, essentially a promise, we can pass it without issues. The next important parameter is builder, a function that builds the interface based on the future state. This function should have two parameters. The first is of type buildContext, which we're familiar with, and the second is of type async snapshot. Notice that this type has a generic. We need to pass the same type as the generic that our future returns. In this case, it's list. It might seem confusing, but let's break it down. First, let's remove explicit type declarations in our anonymous function. As a result, these elements will be of the expected type for the parameter. For example, if we hover over context, we'll see that it's of type buildContext. If we hover over snapshot, we'll see that it's of the correct type too. The FutureBuilder widget itself has a generic. If we look at the future field that we pass, we'll see that it uses the same generic. So, when we pass a future to it, such as the result of our method, Dart automatically knows which type to use for the generic. Also, notice the parameter that controls the builder function. The syntax here might be a little tricky, but we need to focus on this part. It's the type of function that the method expects, and it passes the same generic used throughout the widget. You don't need to understand this mechanism in detail right now, but it's helpful to have at least a basic idea. Let's get back to the method. In this method, we need to return a widget, but we'll do this in a specific way by checking the state of our future. To do this, we need to access the snapshot parameter, which is available to us. It has a connection state field whose type is an enum with certain values. Here, we're interested in the waiting value since we'll be checking for it. If the value of this field equals waiting, we need to return a loading indicator. For this, we'll use a center widget, and inside it, a circular progress indicator. We don't need to pass any parameters to it, and it will have its default appearance. Now, let's display the interface in case the future has completed and returned some data. To do this, we need to check the hasData field of our snapshot. This field returns true if we received a list. For now, let's return a simple text widget in the center, showing the number of items. To access the actual result, we need to use the data parameter. This parameter also has a generic, so in our case it will be of type list. Note that it's of a nullable type. But since we're using a check for hasData and only access the data afterward, we can safely use the exclamation mark operator. As we remember, this operator forces the conversion from nullable to non-nullable. After this, we can use the length field to get the number of items. Next, we need to return something for other cases. Logically, if it's not loading and we haven't received data, it likely means an error occurred. So let's return a text widget with information about what went wrong. The snapshot has an error field that contains error information if something went wrong. Now, let's put everything together. First, we need to use this page in our app. Then, we should call app in the runApp method. Let's run the code. As we can see, a loading indicator appears on the screen, followed immediately by an error. Notice that there's no information about this error in the console, meaning it's being caught and handled internally. The issue is that we're using the body field from the response, but we're not decoding it. This field is of type string, so we're trying to convert a string into a list, which is causing the error. Let's fix this by adding JSON decode. Let's rerun the code. This time, as you can see, there's no error. Everything works perfectly. First, we see the loading indicator, followed by a successful response. Keep in mind that we haven't added any data yet, so the current count is 0. Today, we continued exploring network requests and looked at how to connect them to the interface. In the next lesson, we'll continue this topic and add the ability to send data to the server. If you have any questions, leave them in the comments, and don't forget to like and subscribe to the channel so you don't miss new videos. Thank you for watching, and see you in the next lesson.